All right, now we're going to look at how to solve absolute value inequalities. In order to do that, we're going to refresh on how to solve an absolute value equation first. So we're going to do this warm-up question together. Negative 2 times the absolute value of x plus 3 plus 5 equals 3. We want to isolate the absolute value first. That's always going to be the first step, is to isolate that absolute value. So we do that first by subtracting 5 off of both sides. We get negative 2. Absolute value of x plus 3 equals negative 2. Then we're going to divide both sides by negative 2. We get the absolute value of x plus 3 is equal to anything divided by itself is 1. So absolute value of x plus 3 equals 1. That means that either x plus 3 has to equal positive 1 or x plus 3 equals negative 1. So we have a positive case and a negative case. If we subtract 3 from both sides, we get x equals negative 2. Here, if I subtract 3 from both sides, I get x equals negative 4. So, let's see here. We got to check our answers. So we're going to check each one, negative 2 and negative 4. So absolute value of negative 2 plus 3 equals 1. Okay, well, negative 2 plus 3 is 1. And the absolute value of 1 is 1. So that checks out. And then we'll try that again. Absolute value of negative 4 plus 3 equals 1. Negative 4 plus 3 is negative 1. And the absolute value of negative 1 is 1. So that checks out. So I have two good solutions. So in my solution set, I would say I have negative 4 and negative 2, just like that. All right, so same process with solving an inequality with just a slight tweak. All right, so we are still going to isolate the absolute value first. That is still step number 1, and step number 2 is still to create two separate inequalities. Just like we had the two cases with the equations, we're going to have two cases with the inequalities, one positive, one negative. So, if the absolute value is greater than or less than, we're going to use the word or. If the absolute value is less than or equal to, we're going to use the word and to separate them. Or answers, we're not needing an overlap, so any answer is a good answer. And answers, we are looking for an overlap. They both there should be two arrows over top of the areas that are good for an and answer. Remember, when you divide or multiply by negative, you got to flip the sign. All right, so first off, we got a absolute value of x plus 5 minus 5 is less than 7. So again, isolate the absolute value first. We add 5 to both sides. Absolute value of x plus 5 is less than 12. All right, so now we're ready to split this into two cases, one positive, one negative. So x plus 5 is less than 12, and x plus 5 is, we're going to flip the sign because we're multiplying or dividing by negative 12. X plus 5 is greater than negative 12. All right, so subtracting 5 off of both sides, I get x is less than 7. Here, subtract 5 off of both sides, I get x is greater than negative 17. So now I'm going to plot these 2 points on the number line. Start with 0 in the middle. 7 is positive, so it's to the right of x, or to 0, and negative 17 is negative, so it's to the left of 0. Above 7, I'm going to have an open circle at 7, and I'm going to have an arrow going to the left because it's less than. At negative 17, I'm going to have an open circle with an arrow going to the right because it's greater than. Now, this is an and. Since it's and, that means I need an overlap. So I'm looking at this area where there's two arrows above it. So this area here between negative 17 and 7, but not including negative 17 and 7, that is where my solution set lies. All right, next up, Absolute value of 4x minus 8 minus 5 is less than or equal to 11. We're going to add 5 to both sides. I get absolute value of 4x minus 8 less than or equal to 16. All right, so 4x minus 8 less than or equal to 16. And, because it's less than, and 4x minus 8 is greater than or equal to negative 16. So we flip the sign when we multiply by a negative. All right, so to solve this, we add 8 to both sides. I get 4x is less than or equal to 24, and then divide by 4. And I get x is less than or equal to 6. And on the right, add 8 to both sides. I get 4x is less than or equal to negative 8. Divide both sides by 4. And I get x is greater than or equal to negative 2. So, again, plot a 0 in the middle. 6 is on the right. Negative 2 is on the left. Above 6, I'm going to have a closed circle with an arrow pointing to the left because it's less than or equal to. At negative 2, I'm going to have a closed circle with an arrow pointing to the right because it's greater than or equal to. And again, I'm looking for that overlap where there's 2 arrows above it. And this time it's between the 2 spaces. So, I forgot to mention on the last one. I'll go ahead and back and do that in a second. Let's go ahead and do interval notation. So interval notation for this one would be bracket, negative 2, comma 6, followed by a bracket. And we use brackets because there's a solid circle at negative 2 and at 6. Over here on this last one, I'll go ahead and do that again. We got a parentheses, negative 17, comma 7, parentheses again, because we have parentheses because the circles are open. So, move on to the next page. We got the absolute value of 6x plus 3 over 2 plus 5 is greater than or equal to 11. So, I want to subtract 5 off of both sides, and I get the absolute value of 6x plus 3 over 2 is greater than or equal to 6. Now, how do I get rid of that 2 off the bottom? Well, it's being divided by 2. So to undo division, I multiply. So I'm going to multiply both sides by 2. So that leaves me with the absolute value of 6x plus 3 is greater than or equal to 12. Now that I've isolated the absolute value, now I can split it into 2 cases. So 6x plus 3 is greater than or equal to 12. Or, because it's greater than, we use the word or, 6x plus 3 is less than or equal to negative 12. All right, so we solve these separately. Subtract 3 from both sides. Get 6x is greater than or equal to 9. Divide both sides by 6, and we get x is greater than or equal to 3 halves. And on this side, we're going to subtract 3 from both sides. Get 6x less than or equal to negative 15. Then we divide that by 6. And I get x is less than or equal to negative 5 halves. So, 0 in the middle. Do 3 halves over here. Negative 5 halves over here. At 3 halves, we're going to have a closed circle. Arrow going to the right. At negative 5 halves, we're going to have a closed circle. Arrow going to the left. Now, again, we do not need an overlap because this was the word or. So if there's any arrow that is above it, it is a true statement. So the way we write this is we're going to, in interval notation, is we're going to start at negative infinity. Always read from left to right. So negative infinity to negative 5 halves. Then we're going to have a bracket because negative 5 halves is a closed circle. Then we're going to have the U for the gap. Then we're going to have a bracket because it's a closed circle at 3 halves. And that goes on forever towards positive infinity. All right, so there that is in interval notation. All right, so example 2, negative 2 times the absolute value of x minus 3 is less than or equal to negative 6. So the first step is to divide by negative 2. We want to isolate the absolute value. So absolute value of x minus 3, and because we divided by a negative 2, I have to flip the sign. So it's greater than or equal to negative 6 divided by negative 2 is going to be positive 3. So now I'm going to split this into two cases, x minus 3 greater than or equal to 3, or x minus 3 is less than or equal to negative 3. Okay, so add 3 to both sides. I get x is greater than or equal to 6. Add 3 here to both sides. I get x is less than or equal to 0. So now I can plot 0 and 6. At 6, I'm going to have a closed circle with an arrow going to the right. At 0, a closed circle, arrow going to the left. Again, it's or, so that means I'm just looking for the area underneath at least one arrow. So it's everything to the left of 0 and everything to the right of 6. And in interval notation, that would be negative infinity. We have a closed circle at 0. So we have a bracket, a gap between, I'm going to do a better U there, a gap between 0 and 6. Then we have a bracket, 6, comma, positive infinity, close the parentheses, and that's it. All right, example 3, 5 times the absolute value of 2x plus 28 plus 6 is greater than negative 24. So again, we want to isolate the absolute value first, so we subtract 6 off of both sides first. 5 times the absolute value of 2x plus 28 is greater than negative 24 minus 6 is negative 30. Then I divide both sides by 5. I get the absolute value of 2x plus 28 is greater than negative 6. Well, here's the deal. No matter what I put in for x, regardless of what I would pick, this is always going to be a true statement because my last step is to take the absolute value, right? And the absolute value is always going to make that number positive. So even if I had a huge negative number, if that was negative 1 million for my x, multiply that by 2, that's negative 2 million. Then I add 28 to that, so that's negative 1.9, a whole bunch million, right? And so, very negative number. However, my last step is to take the absolute value, so that means I'm making that negative number positive. And because that is my last step, that whatever's on the left side there will always be positive. And no matter what positive number I pick, it's going to be bigger than negative 6. So, therefore, because this is always going to be true, our solution set is all real numbers. So that means the entire number line is represented. Now, just in case you forget, you forgot to use logic when you're solving this, you can go ahead and continue on this path just like we've been doing. If you solve it correctly, 2x plus 28 less than positive 6. All right, so subtract 28 from both sides. I get 2x is greater than, let's see, that's going to be negative 34. Then divide both sides by 2. I get x is greater than negative 17. Over here, subtract 28. 2x is less than negative 22. Divide both sides by 2. I get x is less than negative 11. So at negative 17, let's see, they're both going to be to the left of 0, so I can put 0 over here, and put negative 11 there, and negative 17 here. So at negative 17, I'm going to have an open circle with an arrow going to the right. At negative 11, I have an open circle with an arrow going to the left. Now, remember, this is an OR statement, so I just need to pick all of the areas underneath an arrow. Well, the whole line is underneath an arrow. So therefore, my interval is going to be negative infinity to positive infinity. And so x really can be any number. It's always going to be true. All right, this last example, hopefully you've tried this. So we got negative 8, absolute value of x plus 14, greater than or equal to negative 17 minus 7. That's going to be negative 24, divide both sides by negative 8. The absolute value of x plus 14 is greater than or equal to, that's going to be 3. Negative 24 divided by negative 8 is positive 3. So now I'm ready to split that in two cases. X plus 14 is greater than or equal to 3. And since it's greater than, it's going to be or x plus 14 is less than or equal to negative 3. So if I subtract 14 from both sides, I get x is greater than or equal to negative 11. Subtract 14 from this side, I get x is less than or equal to negative 17. So, again, 0 is over here, at negative 11, at negative 17. Closed circle at negative 11, arrow going to the right. Closed circle at negative 17, arrow going to the left. And this time, my solution set does diverge. So it's not going to be all real numbers as my solution set. But I did have the same solutions as I did last time, negative 17 and negative 11, just with arrows going opposite directions. All right, so my solution set this time, my interval, so it goes from negative infinity to negative 17. And at negative 17, I have a bracket. And then there's a gap until I get to negative 11 with a bracket because of the closed circle, going towards positive infinity, forever to the right. All right, that does it for this lesson. If you have any questions, please shoot me an email or send me a message on Canvas. Have a great day.